All right, so our next section is activity 8, where we're going to be talking about complex numbers again. Complex numbers are imaginary numbers, so that little I. So today we're going to be doing some operations, so adding, subtracting, and multiplying complex numbers. So we're in our Springboard book. We're starting on page 126. So you might want a pen and a calculator for today's lesson. Okay, so we're going to start with performing addition and subtraction of complex numbers. So a complex number is just something in the form of A plus BI. So you have a real part, they call it, and an imaginary part. That should say imaginary. My pen's going a little in and out, so use that messiness. Okay. So if we're adding and subtracting complex numbers, all we're really doing is combining like terms. Okay, so you're going to combine the real parts together and the imaginary parts together. So you can kind of think of the I kind of like a variable, okay? Just like you would with x's and constants, it's the same thing. So let's look at these examples, A, B, and C. So in A, we have 6 plus 5i, and we're going to add that to 4 minus 7i. So again, we can only add up like terms. So if I add these, 6 plus 4 is 10. Okay. 5i plus a negative 7i, those are like terms because they're the both imaginary parts. Well, 5 plus a negative 7 gives me negative 2. So we'd have negative 2i. Okay. Let's look real quick at, let's say, 5. So if we have negative 5 plus 3i, and I add that to negative 3 minus i, again, add up your like terms, so we get negative 8 here. 3i plus a negative I is a positive 2i. Okay, so why don't you guys try C, see if you can add those together. What is 2 plus 3i if we add that to negative 2 minus 3i? Okay, well, actually for this one, 2 minus 2 would cancel, and so would 3i minus 3i. So that one ended up actually being 0. So not too exciting for that example. Let's jump to the next page now, and let's look at these examples. So some subtraction. So for example, in A, we have 12 minus negative 5 if we add our real parts or subtract our real parts together. So if you need to kind of do the work on the side, if we have minus minus, we know that turns to plus plus, right? So this actually becomes 12 plus 5, which is 17. And then if I have negative 13, and we subtract 4i, well, a negative minus a number gives me a bigger negative. So this becomes negative 17i. So just be careful with subtraction with your integer operations. One trick you can do is you could change this to addition and then just flip the signs of everything that comes after it, and then it's just a combining like terms problem. That might make your life a little easier there. Looks like I got the correct answer. So I'm going to have you guys try B. Now, even though that's fractions, they had the same denominator, so it's not going to be too bad. So what is 1/2 minus I added to 5/2 plus 9i? What did we get there if we add those together? Well, 1/2 plus 5/2 gives me 6/2, which ends up being 3. Negative 1 plus 8 gives me a positive 8i. So there's your answer, 3 plus 8i. Okay, we're not going to do 7 because of those radicals in it, so let's just do 8. I'm going to have you guys try this one on your own. So again, look at all of your like terms, so add up. So even though this is 3 parts, you have an 8 minus 3 plus a negative 5. What do you get there? Okay, then you have a negative 5i minus a 5i plus a 10i. So again, just take it one thing at a time, watch your integer operations, but solve D for me. Okay, actually, same thing. All of this kind of cancels out. You should have got 0 plus 0i, which would just end up being 0. Okay, so that's addition and subtraction. Not much to it, just combine like terms. Real numbers with real numbers, I numbers, so imaginary numbers with imaginary. Okay, we're going to skip now down to multiplication. So let's look at these rules right here. So for multiplying complex numbers, it's the same thing as when we multiply binomials, okay? So for these problems, we're going to do the same exact thing. We're going to double distribute or FOIL as we know it. There's just one thing we have to point out here, and it's on the next page. It's this math tip box right here. So it's properties of I. So in the back a couple weeks ago when we talked about I originally, okay, we said that I was the square root of a -1. So I happened when we had the square root of a negative number. So the one thing we actually have to know is this one here. If I square this, so if we have the square root of -1, square root, pen is acting, okay. Pen, here we go. Square root of -1, and I square that. All it does is cancel the square root. So I squared is the number -1. So you need to know that to do these problems. So I'm just going to write this down over here. Okay. I squared is equal to -1. So where we use that is this part right here. So when we FOIL it out, we're going to get an I squared. I squared, we substituted -1 for it. So it's always going to flip your sign. So this part here ended up becoming +15. Okay, so let's just put it to use here on the bottom. So let's look at A. I'm going to do my work at the end here to kind of give myself a little bit more space to work. So we're going to take 6 plus 5i and multiply by 4 minus 7i. Okay, so I'm just going to distribute this like I normally would any other binomial. So my first terms, so 6 times 4 is 24. Then my outer terms, 6 times -7i is -42i. Then we have my inner terms, so we have 5i times 4, so that's +20i. And then my last terms here, it becomes -35. I times I is I squared. Okay, so now we're just going to kind of clean some stuff up. I squared is going to become a -1. So this actually ends up being -35 times -1 will give you a +35. So let's just rewrite this part. So the final thing we have to do for our answer is just kind of combine up our like terms. So we have 24 plus 35. So 24 plus 35 is 59. And then our like terms right here, we have a -42 plus 20 is going to give me -22i. And that's your final answer. So your final answer should always look like this. It's going to have two parts, a real part and an imaginary part. So let's do one more. Let's look at B. So that is 2 minus 3i. We're going to multiply that by 3 minus 2i. Okay, so again, just going to FOIL this. So 2 times 3, that's 6. 2 times -2i is a -4i. My inner term, so -3 times 3 is a -9i. In my last terms, we have a negative times a negative. So that's going to give me a +6. I times I gives me I squared. Okay, but again, I squared is going to turn to a -1. So that means I'm going to make this a -6. So let's see what we end up getting here. I'm going to kind of combine these up. So we get a 6 minus 6. That's going to end up canceling. So I'm just going to put 0 for right now. These like terms in the middle, we have 2 i's. So -4 minus 9 is going to give me a -13i. So you can keep the answer like this with 0 minus 13i, or we can just rewrite it as -13i. Okay. So again, we kind of treat these problems exactly as we would normal problems that we've seen before. So if it's multiplying, all you're doing is just distributing. The only thing that's special is the I squared being -1. So just make sure anytime you have an I squared, it's just going to flip the sign of whatever number it's with. Okay. And then if we're adding or subtracting, all you're doing is combining like terms. So nothing too crazy with those either. So I'm going to have you guys just try a problem. So on the last page, on page 128 here, there's 3 possible examples. So in number 8, there's an A, B, or a C. I'm going to have you guys just pick one of those. Try one problem on your own and see if you can actually solve it. Okay, so depending on what problem you picked, here are the answers. Okay. So all of these actually ended up being what's called conjugates. We'll learn about that a little bit more later. But the I terms actually all canceled out after you did the I squared. So those are kind of little different ones. But the answers were 34, 52, or 65.